Hello. Greetings, everyone. I trust you are well. Yeah, welcome to the session for mathematics. Today, guys, I'll take you through the trigonometry for grade 12, particularly on the general solutions. Right. Let me just try to open one document so that I share, so that we start with the general solutions for grade 12. Right, just a minute, guys. Just a minute. Okay, let me try to share. Yeah, I'll just open the Word document so that I'll just use it to summarize whatever I wanted to talk about. Just a minute. Let me try to move this side. Okay. Yeah, let me increase the size. First of all, I'll take you through the trigonometry for grade 12 on the general solutions. Right. What is it that you need to know when you are solving general solutions problems? Okay, yeah, I'll just use the... Right, I'll first take you through the rules that you need to follow when you are solving general solutions. Number one, we'll talk about the general solution for sine. That says if sine of an angle equals to A, whereas A is it's an element between -1 and 1. This is just a condition for sine. So if sine of an angle equals to A, where A is an element between -1 and 1, in order to determine the general solution for sine, which is actually the angles, when you determine the general solution for sine, sine always have two solutions. So, and how do you find these solutions? Then we make the arc sine, or the second function, sine of A plus K times 360 when K is an element of integers. So this is the general solution for sine, the first one. And to get the second one, then you're going to say 180 minus the first one plus K times 360 when K is an element of integers. So it means when we want to determine the general solution for sine, always you have to get two solutions. So the first one is the second function, sine of A plus K times 360, where 360 is actually regarded as the period of sine. And how to actually calculate this period? The period for sine, it's 360 divided by B. And this B is actually the period factor. And from our expression here, the B is just the coefficient of our angle. So it's here, it's 1. So here we use a period of 360 degrees. Then now again, the second one, it's 180 minus the first answer, which we call the reference angle actually. Then now, plus K times 360 when K is an element of integers. So always when they say determine the general solution, and you find that you're using sine, then you must always have two answers. The first answer and 180 minus the first one. So this is what you need to know when you're determining the general solutions for sine. And the question is, why are we actually using a period of 360? Is that when we draw the graph for sine, the graph for sine usually like it starts from 0, then it will have something like this in terms of shape. So usually a graph of sine complete a cycle, which is called the period after the 360 degrees. But it's actually affected by the period factor, which is actually the B, with a maximum of 1 and a minimum value of -1, which is actually the range. That's why when we say, like in terms of the difference, when we say if sine of an angle is equals to A, then A is between -1 and 1. It's because of this. It has a maximum value and a minimum value of -1 in terms of its range. But it changes based on the function. Then now the second one, move on to the second one. Say, this one is for cos. It says, if the cos of an angle, if cos of alpha equals to A, where A is an element, A is an element between -1 and 1. If you want to determine the general solution for sine, let me say for cos, we're gonna get two answers. And from here, we allow plus or minus with the second function, cos of A plus K times 360 degrees when K is an element of integers. So in other words, when we determine the general solution for cos, we need to accept plus and minus. Why are we allowing plus and minus? Is that in terms of, if we draw our reduction, a Cartesian plane in terms of reduction formula, cos is positive in the first quadrant and also in the fourth quadrant. And if we are measuring angle anti-clockwise, the first quadrant will actually, that's where the cos is positive. And also in the fourth quadrant, the cos is also positive. And in the fourth quadrant, that's why we have a negative angle. So that's why we say, whether you're using negative angle or positive angle, then the cos will always be positive. So these are the general solutions for cos. So we allow plus and minus. We allow plus and minus. Now, moving on to the third one. This one is for tan. For tan, when we're determining the general solution for tan, we're going to say if tan of an angle equals to A, but under tan, we're not going to give any restrictions, unlike a sine and cos, because for the graph of tan actually does not have maximum and minimum value, unlike the cos and sine, because this one actually has asymptotes. So in terms of that, then the graph actually, it's something like this. So you see that does not have the maximum and the minimum. So that's why it does not have any boundaries, unlike sine and cos. Then now, from here, okay, just a minute, guys. I will come back to you, just a minute. Okay, now we can proceed. I apologize, guys. I was attending to something. All right, then now, in terms of this one, right, you can see that. Okay, just a minute. I don't know what happened here. Okay, let me unmute again. Okay, let's proceed then. It will. Okay, as I was saying that when we're dealing with sine, say tan, to determine the general solution for tan, with tan we're going to say alpha equals to the second function, tan of A plus K times, here we use a period of 180 degrees when K is an element of integers. So it means when we want to determine the general solution for tan always have one solution with a period of 180. But for sine and cos, sine has two solutions. The first one, which is the first reference angle, then 180 minus the reference. Then with cos, we allow plus and minus with a period of 360 degrees. Then whereas tan alpha equals to A has one solution. So these are the things that you need to know when you want to determine the general solutions for tan. All right, let's be hands-on. Let's go through the examples in order to see how to use these rules whenever you're determining the general solutions. Okay, let me try to erase here so that we continue. I hope you're following, guys. So sine and cos uses a period of 360. Then tan uses a period of 180 degrees. But for tan, it has one solution, unlike cos and sine. Okay. All right. Then now let's just do one example. But however, here I will involve the use of double angles and compound angles. I didn't just take you through the double angles because this is for grade 12. Remember, we have double angle for sine, which is sine 2x is equals to 2 sine x cos x. Whereas for cos, it has three equations: cos squared x minus sine squared x, 1 minus 2 sine squared x, and 2 cos squared x minus 1. All right, let's say, just for an example, you are told to, like, just an example. Let's say you are asked to determine the general solution. Determine the general solutions of, okay, let's say you are told, okay, given, let's say you have sine x equals to cos x, and you want to determine the general solution for this expression. Right, we know that when we determine the general solutions, we need to first, like, resolve our expression, maybe try to look for common expressions or try to simplify it. Then from that we are able to solve. Now, first of all, here we want to solve for x, but we want to find the general solutions of this expression. Looking here, we have both sine and cos. And having both sine and cos, let's look at the angles. The angles are the same. So we have x there and we have x there. So what does it mean? It means that if the angles are the same like this, what we can do is we can resolve this to have tan, because we know that tan of an angle is sine over cos, because the angles are the same. So to do this, it means now we have to, because the angles are now the same, we can resolve this to have tan, because we know that tan of an angle is sine over cos. So it means what we're going to do, we have to divide both by cos x. Why divided by cos x? You want to end up having tan. So we're going to have sine x divided by cos x, and cos x divided by cos x. So sine over cos, this becomes sine 2x, sine x, then this one gives us 1. So now we have simplified these trig ratios into one single ratio. So you see now, it means you want to determine the general solution for tan. And we know when we are determining the general solution for tan has only one solution with a period of 180. So it means we're going to say x equals to the arctan, or the second function of 1 plus k times 180 when k is an element of integers. And this becomes x equals to second function tan of 1. I believe this will give us 45 degrees. So you're going to have 45 plus k times 180 when k is an element of integers. So this is the general solution for our expression. Okay, just a minute, guys. I want to check something here. Okay, right. Then now from here, okay, guys, let me pause here. Just let's proceed. I apologize, I was still busy with something. Right. Then now you see that here we just resolved, like we resolved this to have tan because the angles are the same. Now let me try to change the question now. Okay. Okay. Let's say now we have the following. We have this is the second one. Let's say now we have now we have like this is the second one. We have sine 2x equals to cos x. Right, we still want to determine the general solution. Here we have sine 2x and here we have cos x. Now, if you look at the two ratios, we have sine and we have cos, but the angles now are different. Here the angles were the same, now the angles are different. And we know if the angle now are different, we cannot resolve this into tan. So it means we must come up with something else. So what can we do here? Okay, fine. We have sine 2x. We know sine 2x. This is a double angle. This is a double angle for sine. So it means now we have to expand this as 2 sine x, 2 sine x, sorry guys, 2 sine x cos x equals to cos x. So it means we expanded sine 2x is double to 2 sine x cos x. Then we transpose the cos x to the left-hand side. So we're going to have 2 sine x cos x minus cos x equals to 0. So you can see now that we have a common factor between the two terms, and the common factor now is cos x. So we've taken cos x as the common factor. So we're going to remain we're going to remain with 2 sine x minus 1 equals to 0. Then we can say cos x equals to 0, or 2 sine x minus 1 is 0. Then cos x equals to 0, or then we write this. This will have sine x equals to 1 over 2. But we know that we have to determine the general solution of the two expressions. And to do that, since here we have both sine and cos, which means we're going to have 4 general solutions. Because remember why I'm saying 4? Cos has 2 solutions, like which will have the same angle but will differ with the sign, because we're going to have plus and minus. So we're going to start with the first one. It's okay, fine. We know when we are determining the general solution for cos, it's going to say cos x equals to 0. Okay, let me just write both of them. So when we determine general solution for cos, the angle x here, so it means going to have x, it's plus or minus. Second function cos of 0 plus k times 360 when k is an element of integers. That is the first one. Then the second one, to determine the general solution for sine. Sine always have two answers. And how do we find them? So we're going to say second function sine half plus k times 360 when k is an element of integers. And how to determine the second one? 180 minus the first answer plus k times 360 when k is an element of integers. So here it means the first one we're going to say x is plus or minus. Then we're going to have second function cos of 0. I think this will give us plus minus 90 plus k times 360 when k is an element of integers. Then now with this one, then we're going to say x equals to second function sine of half. I think this one will be 30. Yes, it will give us 30. So we're going to have 30 plus k times 360 when k is an element of integers. And what is the second one? 180 minus the first one, which is 180 minus 30, which will give us 150 plus k times 360 when k is an element of integers. So it means now you see that we have 4 solutions. But in most of the cases, especially when we have negative angle, we can change negative angle to be positive. How can we do that? What we can do, you can say, if we don't want to write it like this, you can say x equals to 90 plus k times 360 when k is an element of integers. Then instead of using the minus 90, you can say with the minus 90, we can add the angle because it's negative with the period, which is 360 degrees. So we're going to have minus 90 plus 360. This will give us 270 degrees. Plus k times 360 when k is an element of integers. But in most of the cases, even if you leave the answer with negative, like even if it's like this is still fine. And why are we calling this a general solution is that if you plug these angles where there is x on cos, both they must satisfy your equation. For example, cos 90 is 0 and cos 270 is also 0. Even if you use minus 9. Same applies, even if you use 30 here, they will both satisfy the expression or the trigonometric function. Especially in grade 12, guys, you need to make sure that you play around the double angles and the compound angle. I believe you are following. Right, let me come up with another example. Okay. There are a lot of examples that I believe you can go through. And remember, in trigonometry, you need to make sure that you must know somehow you can take the common factor. You can factorize your expression. You can use the quadratic formula. There's no problem with that. For example, let's say now we're given this. Okay? Let's say we're given, okay, let's say we have, okay, let's say we're given cos 2x equals to sine x. Cos 2x equals to sine x. Then you are asked to determine the general solution. So when we look here, we have cos 2x and we have sine x. The angles are not the same. This one is double. This one it's not double. So you see that we can no longer use tan, because tan allows us when the angles are the same, then we can use tan. Even if we had sine 2x and cos 2x. You see, we're still going to get tan because the angles are now the same. If the angles are the same, then you can resolve to tan. Now, with this one, now we're given cos 2x equals to sine x. The angles are not the same, so it means we can no longer resolve this into tan. So what can we do, right? We're in grade 12. So since this one is a double angle, it's a double angle, but it's a double angle for cos. And we know the double angle for cos equals to 3 equation. So which means here we need to work smart and try to look for which one can we substitute here in order to solve this. And the best way to choose the correct formula here, you are guided by what you are having here. Here we are having sine x. And what does it means here? We must go and take a double angle for cos that has sine only. Which one? The second one. So you can say we have 1 minus 2 sine squared x equals to sine x. So what we can do is we can transpose the expression on the right to the left and write this in a standard form. So we're going to have, okay, 1 minus 2 sine squared x minus sine x equals to 0. Then now we can write this in a standard form as a quadratic expression. We're going to have minus 2 sine squared x minus sine x plus 1 equals to 0. And we multiply everything by negative, then this will give us 2 sine x plus sine x minus 1 equals to 0. And when you look at this is actually a quadratic equation. It's ax squared plus bx plus c. The only difference now we're using the x. I'm saying here we're using sine x instead of the x squared. But it's still a quadratic expression. So what we can do here, we can try to factorize this expression. Remember, there are many ways to skin a cat. Some of you can use quadratic formula. You can still do a letting method if you are not used to this. There's no problem. So, but by looking at this, we can now say, okay, we can now factorize this expression, make 2 pairs of brackets. What are the factors of 2 sine squared x? This becomes 2 sine x and sine x. Factors of 1, so we have 1 and 1. And we want the middle term to be 1 here, minus sine x. But when you multiply the sign here, they have to give us a negative sign. So which means we have to use opposite sign. So because we want to get, so it means we're going to have plus here. And here we're going to have minus. Why? Because 2 sine squared x times sine x is, I'm saying 2 sine x times sine x, 2 sine squared x. 2 sine x multiplied by positive 1, this will give us positive 2 sine x. Then negative 1 times sine x will give us negative sine x. So you see that 2 sine x minus sine x is positive sine x. So this is the correct one. And negative times positive is negative. So everything's okay. So what we're going to do, we're going to say, okay, here we have 2 sine x minus 1 equals to 0. Or sine x equals to minus 1. Then this will become sine x equals to half. Or sine x equals to minus 1. We know when we determine the general solutions for sine, we also have 2 answers. So what does it mean? Here it means we're going to have 4 of them. So I'm gonna repeat x twice here. Same applies here. I'm going to repeat x twice to indicate that we determine general solutions. So here we're going to say second function sine of 0.5. Whereas this one will give us 30. So we're going to have 30 plus k times 360. When k is an element of integers. In other book, instead of k, they use n. It's also applicable. It's fine. So you can have k an element of integers. The second one, it's 180 minus the first one, which is just 150 plus k times 360 when k is an element of integer. Same applies. Second function, sine of -1. This will give us minus 90. So you're going to have minus 90 plus k times 360 when k is an element of integers. And how do we determine the second one? 180 minus the first one. What is the first one? -90. So 180 minus, then this will give us 270 plus k times 360 when k is an element of it. So these are the answers. These are the general solution for the expression. I believe you are following. I believe you are following. Right, then now I want us to proceed with other questions, particularly like when we are solving expressions that are involving compound angles. But before that, let's first do another example where we can actually talk about the cofunctions. Remember, there are many ways to skin a cat. Okay, I want to take you through the use of cofunctions when we are solving general solutions. Okay, let's talk about them. Right, we know that when we have either 90 or 270, if we use them on trig ratios, the ratios has to change because these are regarded as the cofunctions. So now what does this mean? It means that, for example, if we have, we know that when we have, let's say, when we have, let me just write them here, cofunctions. So let's say you have the sine of an angle. We know in terms of cofunction, sine of an angle is the same as cos of 90 minus an angle. So these are the cofunctions because 90 minus an angle is in the first quadrant, where cos is positive. But because of 90, the cos will change and becomes sine. So it means from now on, we can change sine to cos by using cofunction. Or we can also change cos into sine by using cofunction. Particularly 90 minus. But it's not about 90 minus. So what does this mean? For example, we have seen that when we have, let's say, when we have sine x equals to cos x, we solve this expression by using tan, because we know since the angles are the same, then we can divide both by cos. And dividing by cos, then this gives us tan x equals to 1. And we know when we determine the general solution for tan, it will have one answers then with a period of 180 when k is an element of integers. So it means if we do not want to use this approach, we can still use cofunctions. What do you mean by cofunctions? We can either change sine to have cos, or we change cos to have sine, so that we solve our expression. But if you are changing sine into cos or cos into sine, you must always know that, you must also know the general solution. So it's our choice. So it's either here we say, okay, fine. We have sine x equals to cos x. So our choice would be, we can remain with sine and change cos to have sine. How? It means if I want this to become sine, it means the same as, say, sine of 90 minus an angle. Why? 90 minus an angle is in the first quadrant where sine is positive. But because of 90, then it changes and become cos. See that these two things are the same. So what we've done here, we've changed sine, cos into sine. So we are remaining with sine here. And since we are remaining with sine, it means we're going to use the general solution for sine. And please bear in mind, if you're using general solution for sine, it means the angle that we have changed here, our cofunction here, it's now regarded as the reference angle. It's the first reference angle for sine. We know sine always have two answers. So already we have the first reference angle, which will be 90 minus x plus k times 360 when k is an element of integers. And how do we find the second answer for sine? Because here we remain with sine. So sine, we know we have to get the first answer, and the second one is 180 minus the first. So it's 180 minus an x. So this will give us 180 minus 90 plus x, which is just 90 plus x. So you're going to have 90 plus x plus k times 360 when k is an element of integers. So what we can do is we can solve our expression here. So here we can, on the first one, since remember we said sign must have two answers. So this is the first one and second one. So we can now transpose the minus x to the right-hand side. So this will give us 2x equals to 90 plus k times 360 when k is an element of integers. Then the second one, we can still transpose x to the right-hand side. This will become x minus x. It means it will not give us the answer, this one. So it means we're going to remain with this one only. Because this one will have no solution because x minus x is 0. So since we are solving for x, we can divide everything by 2. It will also affect the period. So we're going to divide it by 2. So it means the x is equals to 45 plus k times 180, where k is an element of integers. So you see that we can still have the same answer as in that method where we changed sine into cos. I'm saying we changed sine and cos into tan. But now another approach would be, remember here we changed the sine into cos. I'm saying we changed cos into sine. So we wanted to remain with sine only. But someone can change sine into cos instead of remaining with sine only. But if you are changing sine into cos, it means here you have to use the general solution for cos. So it means if we say you have, let's say you have, okay, with the same one, sine x equals to cos x. So if we want to change, we want to remain with cos, it means we have to change this one. And do that means I can start with this one and say, okay, I have cos x. And this one I have sine x. I believe you understand what I've done here. So what we can do is, since we want to remain with cos only here, I did not change, I just transpose this. So if we want to remain with cos only, it means you have to change this. This will be cos x. Then here I have to write cos into 90 minus an angle. Because 90 minus an angle, it will still be the same as that. So this one is already our reference angle, the one we have changed. So what does it mean? It means since we remain with cos, we're going to use the general solution for cos. And how to generate general solution for cos? Cos allows plus or minus of the reference angle plus k times 360 when k is an element of integers. And when we say plus and minus, it means we can expand this and say, okay, sorry. Then now, it means now, apologize. It means now, from the expression here, what we can actually do is that we can separate the expression from the plus and the minus. So this will actually give us, the first one will, by removing the bracket, will be x equals to 90 minus an angle plus k times 360 when k is an element. Then we now multiply by negative, so it will be negative 90 plus x plus k times 360. So you see that even if we transpose this, x minus x will still be 0, so it will not give us a solution. But this one, when we transpose, it will say 2x equals to 90 plus k times 360 when k is an element. Then we can divide everything by 2. So x becomes 45 plus k times 360. Oh, 180, I mean to say, because it's also affecting the period. So you see that you can still use co-functions in order to solve equations. Right, same applies with the one that I just did where we had the cos 2x, where we had cos 2x. You can still use the co-functions to solve the expression. It's also fine. There are many ways to skin a cat. Okay? Let me write it again, maybe use the different method. So remember we had cos 2x, it's sine x. So what we have done, we have changed this into double angle. But if you don't want to do that, what we can do, we can use cofunction. Maybe try to remain with cos only. So it means we change this one. This will become cos into 90 minus an angle. So the one that we just changed is now our reference angle. So since we remain with cos, we know cos always have two solutions. So we're going to say 2x is plus or minus 90 minus an angle plus k times 360 when k is an element of integers. Then we're going to have 2x equals to, then we multiply by positive first. So it's 90 minus an angle plus k times 360 when k is an element of integers. And the second one, we have 2x multiplied by negative. So we're going to have negative 90 plus x plus k times 360 when k is an element of integers. And then now from here, what we're gonna do, we're gonna say, okay, fine. Since here we have this expression here, we can now say, okay, this becomes 3x equals to 90 plus k times 360 when k is an element of integers. Then the second one, we can now expand this one. So we're going to have 2x minus x. This gives us x equals to 90 plus k times 360 when k is an element of integers. Then now we can divide everything by 3. 9 divided by 3, then this one will have 30. Unfortunately, the period table will change. 360 divided by 3, then this one will give us a period of 120 when k is an element of integers. And the second one would be minus 90 plus k times 360 when k is an element of integers. Like what I said earlier, that if we do not want, like, we can still rewrite this and say, okay, it means x is 30 plus k times 360 degrees when k is an element of integers. Then the second one, we take this 30 and add with the period. So this becomes 150 plus k times 360 when k is an element of integers. Then the second one, this one, what we can do, we can still say minus 90 plus 360, this will give us, we can still say minus 90 plus k times 360 when k is an element of integers. Then the other one would be minus 90 plus 360. Then this gives us 270 plus k times 360 when k is an element. You see, that is the same answer as in like as the one that we did earlier. Like the one we expanded the cos 2x into 1 minus 2 sine squared x, then we factorize. This is what we got. You can also use it, it's still fine. Still fine. Still fine. Remember, when you're dealing with like in trigonometry, you can factorize, you can take quadratic formula. There's no problem with that, as long as you're able to get the answer. Okay. All right. Let me do the other example. Okay, then now I'll just pick one question. Let me just choose one question. Yeah. Yeah, let's say you have this. It says cos 2x minus 5 cos x minus 2 equals to 0. Then you're asked to determine the general solutions for this expression. Okay. Okay, let us look on this expression. We have cos 2x minus 5 cos x, then minus 2. Here we have 3 terms now. And since we have 3 terms, let's look on the first term. The first term is cos 2x. And what is this, guys? This is a double angle for cos. And remember, the double angle for cos equals to 3 expression. Cos squared x minus sin x, sin squared x, minus 2 sin squared x, and 2 cos squared x. So now, cos squared x minus 1. Now, the question is, which one among the 3 are we going to use here in order to solve our expression? Now, you need to learn to work smart, guys. When you look at this double angle, this one, because it has 3 expressions, you need to first be guided by the next term. The next term says 5 cos. You see that there's cos only. So what does this mean? It means this is a guideline to say, let's go and pick a double angle for cos that is cos only. Then we'll be able to solve our expression. So now, this will be 2 cos squared x minus 1 minus 5 cos x minus 2 equals to 0. Let's write this in a standard form. This becomes 2 cos squared x minus 5 cos x minus 3 equals to 0. So you see that this is a quadratic equation. It's ax squared plus bx plus c. So there are many ways to skin a cat. What you can do if you don't want to factor that, you can say, you can let where there is cos x to be k or anything. So it means this will be 2k squared minus 5k minus 3 equals to 0. Then you try to factorize this. Factors of 2k squared, this become 2k and k. And factors of 3 is 3 and 1, but you want to get 5 here. And the sign that we're going to use here, then we have to use different sign because here we have a minus. So what does this mean? It means you must put 3 here and 1 there. Why? Because this 2k times k is 2k squared. 2k times 3 is 6k. And 1 times k is k. And from this 6, we want to get minus 5. So it means this will be negative and this will be positive because negative and positive is negative. So it means here we're going to have a minus here and there we're going to have a plus. So now what we're going to do is we can now solve for k. So we're going to have 2k plus 1 equals to 0, or k minus 1 is 0. I'm saying minus 3 is 0. Then k will be negative half, or k will be 3. But however, we're not solving for k, we are solving for x. So it means where there is k, we're going to put cos x. So we're going to have cos x equals to half, or cos x equals to 3. But now we know that from our definition, cos must have 2 solutions. But remember we said the boundary for cos says if cos x equals to a, where a is an angle, it's an element between, it's a value that is between minus 1 and 1. So if it's not between minus 1 and 1, it will not give us the answer. So it means here we're not going to have the answer yet. It's not applicable because second function cos of 3, then it will give us math error. So it means we're only going to remain with cos x equals to half. And we know when you determine general solution for cos, we're going to allow plus or minus. So we're going to have second function cos of 0.5. So it will give us 60. Plus k times 360. And k. See that you write like this, or you write it as x equals to 60 plus k times 360. And k is an element of integers. Then the second one we can say to get rid of the minus, to get rid of the negative angle minus 60 plus 360, then this will give us 300. So we're going to have 300 plus k times 360, where k is an element of integers. Remember, there are many ways to skin a cat. There are many ways to skin a cat. Another way would be, guys, remember, somewhere you need to come up with different approaches. If you don't know how to factorize, or you find that it takes time for you, you can just go straight to other things. Okay, fine. You have 2 cos squared x minus 5 cos x minus 3 equals to 0. Then already this is in that form. So a is 2, b is minus 5, then c is minus 3. So instead of writing x equals to minus b plus or minus the root of b squared minus 4ac divided by 2a. We're not solving, like here we have cos x, means you must put cos x here. So, and do the substitution. This will be minus into minus 5 plus or minus the root of minus 5 squared, 4 into 2 into minus 3, everything divided by 2 times 2. So here you're going to have cos x equals to, you see here we got plus minus 6, right? Then now we're going to, okay, sorry. Okay, let me just erase here. So then now it means here we're going to say cos x equals to 5 plus minus the root of, then divide by 4, yeah? So it means we're going to say 25 minus 4 into 2 into minus 3, then this gives us 49. So you see that the first one will be 5 plus the root of 49 divided by 4, then it will give us 3. Or cos x is 5 minus the root of 49 divided by 4, it will give us negative half. Oh, guys, I apologize here. I think I've done something wrong. So here it's supposed to have, we're supposed to say negative half. So it means that value will change. Second function, cos of minus 0.5. So it means we're supposed to say x. I apologize, guys. X, it's plus or minus 120 instead of 60. Plus k times 360. Let's correct that. So it means, like, yeah, you can write it like this. Yeah, you can write it like this, but now you can proceed here and say, okay, fine. Like what I said, okay, this one will not have any solution, not applicable. So here it will give us plus minus 120 plus k times 360 when k is an element of integers. Or you can just write it as 120 plus k times 360 to get rid of the negative angle. Then the second one will be minus 120 plus that period, minus 120 plus 360. And this will give us 240. Yeah, so it's very important, guys, to check your work. You see now, I was supposed to have gone wrong from the expression. So make sure that you check your work, guys. Okay. Then yeah, I wanna take you through the issue of the double angles now. I believe you guys, you are following. Right, let us look on this or other example here, guys. Okay. Yeah, there is another one. I wanted us to go through this together and just come up with an idea on how I'm going to solve this. Okay, here's an example. I think this will be the last one for tonight. Okay, let's say we have this. It says 2 sine x equals to cos x minus 30. 2 sine x equals to cos x minus 30. Then we are asked to determine the general solutions. Number one, let's check. Here we have 2, and here it says x, the angle is x. And here we have cos, and the angle is x minus 30. We know the angles now are different. And since the angles are different, it means we cannot change this to have tan. We change this to tan if the angles were the same. But now, one other thing is, when you look at the two expressions, here we have the coefficient here, it's not 1, it's 2. Which means this, we cannot use cofunctions. We cannot change cos to have sine or sine to have cos because the coefficients here are not, coefficient here is not 1. You see that the issue of cofunctions, remember if we had, let's say we have sine x here and cos 2x, we're going to change, maybe to remain with sine or cos, cofunctions allow us, or we use double angle, but we cannot use tan. But when you look at here, we cannot use the cofunction, we cannot use tan approach. So what does it mean? Like what is it that we are going to do here? Okay, fine. When you look on the expression on the left, it's just 2 sine x, it's just a trig ratio. But on the right, we have cos of x minus an angle. We know here, this is now a cofunction for cos, because we know for cos, we have the cos of an angle, let's say a plus b. This is equals to cos a, cos b, minus sine a, sine b. Same applies. Cos of a minus b equals to the cos of a, cos of b plus sine a, sine of b. Which means here, in order for us to solve this equation, we need to use the compound angle. So this we can expand it using this rule. So this will become, it's cos, so it's cos x, cos 30 plus sine x, sine 30. So we can now resolve this. This will become sine x equals to, what is cos 30? Cos 30 is the same as root 3 over 2. So this will become cos x multiplied by root 3 over 2. This will have sine x multiplied by half because sine 30 is half. If we simplify this, this will give us 2 sine x, then it's root 3 over 2 cos x plus half sine x. But when we check here we have sine x, and there we have half sine. You see, these are like terms, so we can group them together. So we can say we have 2 sine x minus half sine x, then this gives us root 3 over 2 cos x. And now, since these are the like terms, then we can say 2 sine x minus half sine x, then will give us 3 over 2 sine x equals to root 3 over 2 cos x. So here we have sine x, and here we have cos x. We know as long as the angles are the same, we can end up having tan, because tan is the same as sine cos. So it means if you want to have tan here, it means you can divide everything by cos. So it means you're going to have 3 over 2 sine x, then we divide here by cos x. Then 3 over, or 3 over 2, then cos x divided by cos x, because we divided both sides by cos x. So this will give us 3 over 2 tan x. Then this is just 1, it will give us root 3 over 2. So from this expression, if we divide both by root 3 over 2, so it means we're going to have tan x equals to, so it's like, yes, it's equals to root of 3 divided by 2 over 2, then divided by 3 over 2, if I'm not mistaken. This will give us the root of 3 over 3, or I think it's 1 over 3, if I'm not mistaken. Yes. Root 3 over 3 is the answer. But we want to determine the general solution. We know where we remain with tan. So it means tan must always have one solution. So we're going to have x equals to second function tan of root of 3 over 3. And this will give us 30 plus k times, what is the period of tan? It's 180 when k is the element of integers. And if you want to check that we have done it correctly, we can now substitute this angle of 30 into the original equation. We substitute by 30 and substitute by 30 and check if the answers are the same. 2 sine 30, it will give us 1. Then other side is cos into 30 minus 30. Still giving us 1. So this is the correct answer. But if this coefficient here was not 1, like was 1, then we're going to use cofunction to allow us to use cofunction. Instead we use cofunction, we use the compound angle. Because with the cofunction, it means now we can either change sine into cos or cos into sine. The answers will be the same. The answers will still be the same. Because like if the coefficient of sine was just 1, let's say we have sine x equals to cos into x minus 30. So that we use compound angles or double angle. I'm saying cofunctions. The answer will still be the same. Because it means with the compound angle, this was going to be cos x cos 30 plus sine x sine 30. So this will be sine x. Then this was going to be root 2 over 2 cos x. Then this will be half. Then we transpose this one to the right-hand side. So you see that when you transpose, it will be 1 sine x, then it will be half sine x. Then root 3 over 2 cos x. Then we divide both by cos to have tan, this will be half tan x. It's root 3 over 2. So we can either multiply by 2 or divide by half. So this will be the root of 3. Then we make a second function. So second function tan of root 3. So this will give us 60 degrees. So we're going to have 60 plus k times 180 when k is an element of integers. I mean, if the coefficient was 1. But even if it was, even if it's in that case, it means here, what if you have seen that I've used the compound angle. But there's some instance where you find that the compound angle failed, and you have to use the cofunction. Remember, practice makes perfect. So, like here, what we can do, we can sort of find. We had sine x equals to cos into x minus 30. So what I can do is we can change either sine into cos or cos into sine. So here, like, let's change sine into cos. Because with the general solution for cos are straightforward, because just allow plus or minus. So this is now our reference angle, the one we changed. So it means we're going to say x is minus 30. It's plus or minus 90 minus an angle plus k times 360 when k is an element of integers. So if you multiply by positive, this will give us x minus 30. It's 90 minus x plus k times 360. Then you transpose x, then this side, then 30, that side. But with this, it was not going to give us, it was going to give us solution because we're going to say 2x equals to, then we transpose, this would be 90 plus 30 is 120. Okay, with a period of 3. So we divide everything by 2. It will also affect the period. So dividing by 2 here, dividing by 2 and divide by 2, it will still give us this answer here. Oh, it will give us 60, I apologize, this one, with a period of 180. So the main way is to skin a cat, guys. Okay, thank you very much for listening, guys. Wish you the best as far as trigonometry is concerned in terms of general solutions. Thank you very much. Bye. See you again.